Good afternoon, madam.
Good afternoon, sir.
Yes, ma'am. கொஞ்சம் லேட் ஆயிடுச்சு மேம். சாரி ஃபார் தி இன்டரப்ஷன்.
Okay. சரி, என் வாய்ஸ் ஆடிபிளா இருக்காங்க சார்?
ஓகே மேம், கிளியரா இருக்கு. நோ இஷ்யூஸ். ஓகே மேம், we will start the session.
A very good afternoon. A very
volunteers, you can continue.
One and all who have gathered in this virtual meeting. I hope you all have a great day ahead. To make it more delightful, let's kick off this session on innovative techniques in pre-stressed concrete construction, organized by KSRCT IAC, an interactive session with our beloved resource person. It's a gratifying welcome we bring to you on this pleasant afternoon. Hope you all have a great day ahead. To start this auspicious occasion, I would like to call upon Sairam, second year from the Department of Information Technology, to welcome the gathering.
Success is not final, failure is not fatal. It is a courage to continue that counts. It is our pleasure to start this moment by heartily welcoming Sri R. Srinivasan, Vice Chairman of KSR Institution, Dr. K. Tyagaraja, CEO of KSR Educational Institution in absentia, and Dr. R. Gopalakrishnan, Principal KSRCT. We welcome you all today's webinar. I heartily welcome our today's chief guest, Mrs. V. Preetha, Assistant Professor, Department of Civil Engineering, Bannari Amman Institute of Technology, who is here to deliver a talk on innovative techniques in prestressed concrete construction. Basics of intellectual. Now I extend a warm welcome to our President, Vice President, Convener of IIC, student coordinators of IIC, and other core members. I extend my salutation to faculty members and other participants. When you change your thoughts, also remember to change your world. Once again, here I welcome you all to the webinar on innovative techniques in prestressed concrete construction. Thank you, everybody.
Thank you, Sairam. The pessimist sees difficulty in every opportunity. The optimist sees opportunity in every difficulty. With this inspiring quote, let me take this opportunity to invite M.K. Vishnupriyan from the Information Technology second year to introduce our today's chief guest, Mrs. Preetha, to the audience.
Let me take this opportunity to invite our chief guest, Mrs. Preetha. She has completed her BE Civil Engineering in Congo Engineering College. She has also completed her PG in Structural Engineering at Bannari Institute of Technology. Currently, she is pursuing PhD in Steel, Concrete and Composite Structures. She also has membership in professional bodies such as ISTE, IGS, IEL. She has presented in 20 international conferences and 15 national conferences. She also has 3 years of total experience in industry. We are overwhelmed to have you here at our event, ma'am. I hope that we are able to seek guidance and imbibe something from your experience. It is an honor and a privilege for us, ma'am, to have you with us today. We are really thankful to have you here for making your presence despite your busy schedules. On behalf of IIC, we wish all your attempts would result in great success, ma'am. Thank you all.
Thank you, Vishnupriyan. Now I hand over the session to our eminent resource person. Please, ma'am, the floor is all yours.
Given to me from the KSR Institute and IIC cell. Shall I share my screen?
Yes, ma'am, you can share.
Is my screen is visible, sir? Sir, my screen is visible?
Yes, ma'am, it is visible, ma'am.
Yes, ma'am,
Yeah.
visible.
Yeah, thank you. Okay, let me have a short topic today because it is a huge area in Prestressed concrete. I'll be introducing some little bit of innovative techniques what I have enjoyed during my studies. So the today's topic I have given is innovative techniques in Prestressed concrete construction. I think most of you here are exposed to Prestressed concrete construction, and most of you here are exposed to RCC construction. I hope the crowd is being composed of third years and final years, right?
Yes, ma'am, yes, ma'am.
Yes. Okay. So I'll be combining and comparing both the RCC and pre-stress today for a small introductory session. Then I'll be moving to the continuous beam section that is now full-fledged. It has been there in the construction sector. So let me have an understanding of what is mean by pre-stressed concrete section. So in the name itself, we know it is pre-stressed. That is already it has been stressed, where the RCC is not stressed before. In placing a skeletal, that is your reinforcement section inside your concrete, and we are being fulfilled with your concrete, then it has been there for your service life period. That is your RCC, right? So when coming to the picture of pre-stressed concrete, it has been already stressed prior to your construction. It has been stressed. So see here in this first picture, it is an unstressed beam where the beam is being given in the rectangular fashion, and you'll be having a loads that has been acting on the upward of your beam. So when it undergoes deflection, when it has been capturing its load, it will be undergoing deflection. So the deflection is obviously coming down because the load is being acting at the top. So when I introduce the tendons over here and I stretch my tendons, you should imagine that without having any reinforcement, shall I place only tendons? Not like that. The skeletal structure is there. Then I'll be placing an extra tendon there. It has been stretched now. Then after getting all your pre-stressing forces, the tendon will undergo deflection, will take along with your concrete and steel, and it will undergo deflection. During stretching alone, it will undergo an upward deflection. So after it has been deflected, so this deflection has not been seen by your naked eye. இது உங்களுக்கு கண்ணுக்கு தெரியாது, but it has been transferring it as pressure line அப்படின்னு படிச்சிருப்பீங்க. So it has been like a pressure line. So after getting all its loads from your top, that is your dead load and live load, it is again coming to the flat position. That is the deflection has been very small when compared to RCC. So that is why this formation, this sequence of arrangement that we are doing it in pre-stress. So that's why we'll be having a lighter section. We can reduce your concrete quantity and we can reduce your cost in the construction sector. That's why the progress is from PCC, RCC and pre-stress. Nowadays we are moving towards the pre-stress concrete construction. So what is tendon over here is, see here in this picture, the small holes will be there. So this is your tendons. So it is like a wire. The group of wires will form a strand. Then the group of strands will form a tendon. So these are the tendons. We will be having a duct hole inside it. So this picture will resemble the slab element. So the holes will be there and the tendons will be passed over there. So what it will do? That is the next question. Why we are being talking about pre-stressing? So pre-stressed is nothing but at the outside, the final solution will be the entire thing is being compressed. So during the production, it is being compressed. You will be having the final, the result should be in compression. You should not have any tension over there. பிரச்சனையே இருக்காது அப்படின்ற மாதிரி. So everything is compressed. So that is how it is being compressed. When I be stretching my tendon, the tensile forces are being stretched out. So it will be impart all your tensile stresses to your concrete. So the entire concrete will undergo compression. You all know about it. The concrete is good in compression, whereas the concrete is bad in tension. So how to take away the tension is, we can stretch over the tendons over here so that the entire final product will be under compression. That's why we are being now in the process of pre-stressed concrete construction. So this is what I want to deliver, the comparison over RCC and the pre-stress, where we have the reinforcement bars. Along with reinforcement bars, we'll be having tendons over there. In pre-stressed concrete, the load is being applied. When the load is being applied in RCC, you will be having a deflection over here in the downward stream. So the cracks also will propagate from the bottom. So where you have a tensile layer. So during your service life period, service life na enna அப்படின்னா கட்டும்போது டெட் லோட் லைவ் லோட் அப்படின்னு நம்ம படிக்கும்போது டெட் லோட் லைவ் லோட்னு படிப்பீங்க. ஸோ when the people is entering inside your building, that is nothing but the catchment of loads. The live loads will be, you are getting to the building. So that portion is nothing but the service load, right? So when it captures its service load, you will be getting crack in this fashion. See here at the bottom, you will be having a cracks. So in order to avoid those cracks, it is the main duty of pre-stressed concrete to save the section from your cracking. So when I use pre-stressed concrete from the RCC, I can get uncracked with, that is uncracked specimens when it is being subjected to both dead load, live load, or wind load, seismic load, or anything. Okay. So I can save my concrete, I can save my maintenance problem and everything. Everything will be solved out there. Okay. Then see here, this picture, so many bridges, you will be traveling a lot during your lifetime. See here, so many piers are there, so many deck slabs are there. So we'll be having many pre-stressed concrete bridges nowadays. It has been available in the construction industry. So we have pre-stressed girders over there. So you will be having a deck slab and a pavement, and you have a barrier there when your bridge is being closed out. So this pre-stressed girders will be very useful, so that we can make it in a factory yard and we can transport it and we can assemble it there. So no need to construct over here in this water body areas. So it has been free from the construction area. So nowadays precast elements are there. Nowadays we are doing pre-stressed concrete along with the precast industry only. So we are been constructing in the factory yard and we are been transporting it and we are been placing it. So the life is very simple nowadays when we go with this advanced techniques. So this innovative techniques for the long span structures will be still following. So see here, so we have in order to reduce all those piers, we can give a deck slab. Below this, a span will be there with small piers will be there, so that this space will be occupied. The below space we can occupy. Okay. So in case if this system we can adopt it in Pamban bridges, underneath the boat can go there. So கீழே என்ன வேணாலும் நம்ம பாஸ் ஆகி போய்க்கலாம். So if you want to avoid pier structures, we can go for this type of slab arrangements. Okay, so this picture is box girder bridges. So you'll be seeing it in many films, and if you go to Chennai Metro, you can see this box girder bridges. So metros and all, usually they will be box girder bridges. This single box and this is double box girder bridges. So everything is made up of prestressed concrete. See here, the tendons are available here. So small piece wise, we have been manufacturing from the factory yard and we have been assembling it there. So it has been very simple during its construction stage. Only the design part is very critical. So the construction, we need some qualified laborers over there. That is, skilled laborers are needed. That is the one thing, the major disadvantages in your prestressed concrete construction. Then this is the assembling stage of your box girder bridges. See here, the crane has been there to transport it and to assemble it there. So only 2 laborers are there. So we can reduce your labors also, right? Then we have seen so many bridges. I have given you some picture here. So you can guess something now. What is it? What type of beam or slab arrangement is this? Any guesses? Any guesses? Can anybody guess what type of beam or slab is this? No? Okay. I have given a long span, so you can come across that. It is a continuous section, okay? Continuous beam section. So if we have 2 or more supports, we can call that as a continuous beam section. Usually the continuous beam sections are available only for the bridges and for the buildings also if it is very long. Continuous throughout like bridges, because we'll be giving some construction and expansion joints over there. So why we need continuous beam in our construction sector? Why can't we make it as a simply supported and fixed and overhanging sections? Why we need it to be continuous beam? Because if we want to lead a long span structures, we'll obviously go for 2 or more supports. Then those beams are made continuous over your supports. It will make to increase your structural integrity part also. So structural integrity in the sense, if it is having a huge supports over there, so you will be having a continuous positive and negative bending moments over there. So you will be having a structural integrity is very good in your continuous beam support. Continuous in structural integrity is nothing but if one fails, another one will leads to safety. It will prolong to your safety. It will increase your time period. That is what I can say, that it is a structural integrity portion. Then one more thing, the continuous beam will also provide your alternate load path in case of your failure section. That is, if one span is getting failed over there, one part a hinge is being formed there, another part will yield there. நம்ம MOD-ல படிச்சிருப்பீங்க moment redistribution அப்படின்னு. ஸோ ஒரு சப்போர்ட்லேருந்து இன்னொரு சப்போர்ட்டுக்கு மொமெண்ட் ரீடிஸ்ட்ரிபியூட் ஆகும். பேலன்ஸ் அண்ட் கேரி ஓவர் வில் பி ஹேப்பனிங் ஓவர் தேர். சப்போஸ் if a portion A to B column, a car is being moving, if one part is going to fail, another part will yield a lot so that the failure can be avoided. So the moment redistribution will be happening over there in the entire structural system. So you cannot go for the failure of your section. Then in the regions with high seismic areas also, the continuous beams and frames are being usually preferred in your buildings and bridges, because in high seismic risk areas, we have the load path is very different. Whereas it is not dead load and live load, it is a sudden load, it has been hitting your structure. So that in most of the bridges, we will be having a redundancy effect will be there. So this redundancy effect will be handled easily by your continuous beam sections. Then we all know about it. The continuous beam is a statically indeterminate structure. We have studied in analysis what is statically determinate and what is statically indeterminate. So statically determinate, let me brush your basics now. So statically determinate is what if the number of unknowns is equal to your number of equilibrium equation, number of your equations, it is being satisfied. Okay, you will maintain your equilibrium part. So if your unknowns is more, you have so many supports over there. If your unknowns is more, it is not sufficient to determine your internal forces and reaction over there. So that structure is nothing but statically indeterminate structure. If I can ask you whether the statically indeterminate structure is preferred for your buildings and bridges, yes, you can say that. You can prefer for your buildings and bridges because the structural integrity is very high, because you will be having an alternate positive and negative bending moment over there. So if the alternate positive and negative bending moment is over there, if one fails, another one will hit for your safety. So that is what we can go for this continuous arrangement or indeterminate structure in both in buildings and bridges. Then what is the main advantages of your continuous beam sections? For the same span and same section, the vertical load capacity may be altered, may be different, and maybe more. You can give more load also. Nothing will cause a problem over here. Okay. Then the midspan deflection is very less when compared to the simply supported or fixed beam conditions. So the continuous will be having a less amount of midspan deflection. So if the midspan deflection is very less, the depth of the section will also be less. So if I put simply supported beam over there, if I'll be having 750 mm depth, so in 450 mm depth, we can occupy your continuous beam condition. So if the same depth can be adopted, the more load carrying capacity will be there in your continuous beam section. So I can say that continuous beam is very economical in terms of materials also. Okay. Then there is a redundancy in your load path also. So redundancy will play a major role over here in your continuous beam. That is the possibility of formation of your plastic hinges. Let me give the brief idea over there. So you may hear what is mean by plastic hinge formation. Okay. So see here, this is your beam. I'll be drawing a simply supported beam. If it is getting loaded, okay, it will undergo deflection like this. So after getting, you all know, after getting the midspan deflection, that is WL squared by 8 or WL squared by 12, depends upon your support condition. This midspan deflection is attained, that is WL squared by 8 is attained over here. This part will form as a hinge. Hinge is nothing but it will allows rotation. So allows rotation in the sense this part cannot able to take load. என்னால இதுக்கு மேல load எடுத்துக்க முடியாது அப்படின்னு அந்த part சொல்லுச்சுனா, it is been transferring to your supports. This is what you have done in moment redistribution in MOD. When you studied, you have done it in moment redistribution. So this is nothing but carryover to your supports BA, AB அப்படின்னு போட்டிருப்பீங்க. So when it attains your formation, it will drops down to your column, that is your support region க்கு அனுப்பிரும். So if this is continuous, all the supports will do like this. If one support is yielded very quickly, another support will take more time to yield. That is what a redundancy path can be easily maintained in case of your extreme event. ஒருத்தர் அட்டைன் ஆகிறதுக்கு முன்னாடி இன்னொருத்தர் அட்டைன் ஆயிருந்தாலும் one can yield a lot. The time period will be very high. Okay. Then in case of pre-stressing, it will require less number of anchorage of tendon. Anchorage is nothing but the tendon is passed over there. One end you have an abutment. Inner end you will be placing a jack and you will be stretching your tendon, right? So if it is a continuous section, number of anchorages will also be reduced. So ஒரே ஒரு இடத்துல anchorage வெச்சா போதும். அந்த anchorage செட்டப்புக்கு it will be very costly. The end anchorage setup is very costly. So we can reduce number of anchorages also if we prefer continuous beam. That's why mostly all the bridges are being made continuous nowadays. Okay. Then In the same way, the deck joints will also be reduced. So number of deck joints will be reduced, number of bearings will be reduced. So it will be spanning for a long length. So you can reduce your bearings also. Okay. So that if everything is getting reduced, obviously the maintenance part is getting reduced, right? Then what is the major disadvantage? If we have pros, we have cons also. So if we have advantages, we have an accompanied disadvantages of your continuous beam section. That is, the main thing is it is difficult to analysis and the design procedures are very critical. So you could have seen theorem of three moments. So many methods are available. So moment distribution method and மாதிரி நம்ம MOD-ல நிறைய methods படிச்சிருப்போம். So those methods we want to use it, and the design procedures are very critical. Then difficulties in construction, especially in case of precast members. If we didn't join properly, that joint will be having a problem. So that is the one major disadvantages. It will gives you a lot of failures. Then one more thing is increased frictional loss due to changes of your curvature, because your profile is continuous. So you will be having a bending moment profile of alternate positive and negative. The same profile will be maintained for your tendons also. If you have a sign, if you have it like a sine curve, the tendons, the frictional losses will be there. So the change of curvature there in your tendon, it will leads to frictional losses. Okay. Then increased shortening of your beams, leading to the lateral forces on your supporting column. So the beams will get shortened when you observe more amount of lateral forces from your support region, right? Then secondary stresses will also develop, that is due to the long-term process, that is creep, shrinkage, settlement problem. If you have a variation in your temperature, you will be having a secondary stresses. Primary stresses is nothing but it is taken care immediately after it has been assembled. The secondary, it will take large time to develop over there. So these stresses will have a large problem in your continuous beam, right? Then the concurrence of your maximum moment and shear near your supports needs proper detailing, because near your supports you will be having a negative bending moment. Support region you will be having a negative bending moment. So this area should be detailed very properly. So if not, the maximum moment and the maximum supports near near your column region or your support region, whatever it may be, if it is not properly detailed, it will be end up in failure. So that is the main thing. Then one more thing is reversal of moments will happen. Okay. So due to seismic forces, that needs to be addressed well during your analysis and design stage itself. So that is the main thing. Reversal of your moments is nothing but the seismic forces will hit and back. So that is their redundancy part. So it will also follow your normal load path along with your lateral loading conditions also, along with your wind. So everything will be exposed there. So the reversal of moments will be happening. Reversal of moments is because everything is continuous. If it is not getting yielding, it will be taken care by the next. இது எடுத்துக்க முடியல அப்படின்னும் போது அடுத்ததுக்கு போகும், இல்ல அது ரிட்டர்ன் பேக் ஆகுது அப்படிங்கும் போது this beam should take care of all those things. So that problem will also be there. Okay. So how the continuous beams will be arranged in prestressed concrete is, so this is your end span, that is in bridges we can call this as abutments, right? So in this form it is being constructed, and the intermediate supports will in bridges also we have an end and intermediate. Why I want to stress over here is in IS 456 they have given bending moment formulas for intermediate span and your end span condition. So you want to correctly choose what is end span over there, whether the end span is fixed over here or the end span is simply supported, based on which if it is simply supported, your bending moment will be like this, what I am drawing. If it is fixed, again you have a negative bending moment. Bending moment மேல start ஆகும். You have a negative bending moment. So based on your end span condition, everything will be there. Then before going to the analysis part of your continuous beam, let me have a small idea about what is pressure line in a pre-stressed concrete beams. So normally, what I told you is I have placed a cable line or tendon line. That line is nothing but here cable line. So it has been pre-stressed. P is nothing but the pre-stressing force applied to your cable. When it is stretched out, based on your support condition, we are been placing your profile. Okay. So if it is a straight line, it will goes up here. Now stretch பண்ணும்போது it will go like a parabolic line. So this line is nothing but pressure line. Pressure line is nothing but the locus of all your forces connecting with a small line is nothing but pressure line. Now stretch பண்ணும்போது அந்த நான் ஒரு ரப்பர் பேண்ட் ஸ்ட்ரெச் பண்றேன்னா அதுல ஒவ்வொரு பாயிண்ட்லயும் ஒவ்வொரு ஸ்ட்ரெச் இருக்கும். எண்ட் பாயிண்ட்ல ஒன்று இருக்கும், மிட் ஸ்பேன்ல ஒன்று இருக்கும், அந்த மாதிரி. So the locus of connecting all your points over there in your line is nothing but pressure line. This pressure line will be obviously built in your tendon profile. When your pressure line is not properly built also, it will be having a problem. So why this pressure line is very important is, in order to have your support condition, what you are being designed. Suppose if you are designing it as simply supported, you want to get bending moment like this. If you are having a sharp bend, this profile should be there. For that, you want to check all your pressure line. So if your cable is like this, see the orange color line, this is the profile of the CGS. Okay, center of gravity of steel. CGS is nothing but center of gravity of steel. So this is nothing but CGC, center of gravity of concrete. The entire concrete section is divided into two. So in RCC, we could have call it as neutral axis. So here it is CGC. So this profile, when it is being stretched out, it is being going like this. See here, here it is in bottom, here it is at the top. So you'll be having a negative part over here. Wherever you have a supports, it will be going back. So this pressure line will be building over there. Okay. So if it is not built over there, you won't get a proper BMD and SFD profile. Then coming to the analysis, I'll be telling you what are the analysis parts you want to keep it in mind. I'm not going into the problem. It is based on the theory, and most important aspects you want to think over is, certain portions of your slabs are subjected to positive and negative. So you want to check the envelope diagram. Okay. So in StatPro, we'll be getting an envelope diagram, right? So that envelope diagram, we want to check it down. And the beams may be subjected to, sometimes it is partially loading, sometimes it is point loaded, sometimes it is UDL. So the entire pattern of loading will be developed only in the envelope diagram, not in the single diagram. Okay. Then it is like an influence dime diagram, what we have been drawing during your analysis tips, right? The same way you want to draw all those diagrams. From the envelope diagram only, you want to take away how much of pressure you want to give. Then for the continuous beam, pre-stressing generates reactions only majorly at these supports. These reactions will cause additional moments also along your length. It is the biggest drawback in your continuous beam. So that needs to be addressed well. So you want to take care of all your additional moments also along your length of your span. See here. So this is one of the intermediate support. This is the end support. So you will be having a positive bending moment over here, and you have a negative. Positive is obviously, it is not that much critical as negative. In this profile, again, if you lay tendon like this, it will goes down. So it will take only the positive moment, not the negative moment. So in this fashion, you want to place it your profile style. Okay. Then what are the load cases we want to take? Usually we will be having static load cases, that is dead load and live load on each and every span. On live load on will be taking care, right? So all these case studies will be combined together. We'll be giving a load combination. So that load combination needs to be addressed well. So see here. So WDL is nothing but the dead load. Okay, dead load acting. So the moment diagram for your dead load. Okay. So here it is simply supported. So it is coming bottom. Then again negative. Okay. Then when it is live load, the same pathway it will follow your pattern of your loading. When we combine both the two, what will happen? That is our motto. Okay. When it is on one span, see here, when it is on one span, the live load is on intermediate span only. It is not in the end span. So you don't have any moment over here. Then it will be starting from the negative. So again bottom, then positive. So this type of arrangement, this load combinations we want to take during our analysis. That is the main problem over here. So for that, we need to draw a influence line diagram because it is a moving load. In bridges, mostly the moving loads will be taking care. So we have a huge span of your girders also. So we should draw the influence line diagram and will show the variation of your moment and shear for a particular location in your girder and its variations also. And based on all those things, we need to get the envelope diagram for your worst combination. Okay. So this diagram is mostly obtained from the Muller-Bruce principle, what we have studied in analysis, right? So we have certain recommendations from IS 456 also in class 22.4.1, the placement of live loads. We have certain recommendation. First, we need to place live loads in all the span, and we need to place live loads in adjacent spans of your support to get your support moment, and the effect of live load in the alternate span also. ஒன்று விட்டு ஒன்று. Then அதை neglect பண்ணிட்டு என்ன இருக்கு அப்படின்றத செக் பண்ணும். Then live load in all the spans and in alternate span. ரெண்டு கண்டிஷன்ஸ்க்கும் you need to check. இது ஏன் இந்த criteria வருது அப்படின்னா, it is not fully loaded all the time. If one vehicle is traveling in X1, another vehicle is being moving out of X3 or X4 support. Okay. So the entire bridge is being alternatively loaded. So the live load, we need to do it in the trial and error method. When it is all loaded, when it is full of traffic, it has been all loaded, right? When it is not in full of traffic, it has not been all the spans are loaded. So in that criteria, you want to imagine and do a trial and error method. So how the imagination will comes, that imagination will be recommended by the IS 456 also. How to place your live loads. So by placing all those loads, what is the worst effect that should reflect in your envelope diagram, and from that only we will need to calculate your that is your AST part. Okay. So this analysis can also be done by moment distribution, or nowadays we have been using so many software to do all those analysis, Tab Pro, eTabs, like that. Okay. So we have we can also calculate manually by taking your moment coefficients, but it's very tedious process. But if you enjoyed doing it, it will be very simple. Okay. Then it is you should note that the effect of pre-stressing force is not included in your envelope diagram. Only for the static load cases, only for your dead and live load cases, it's been taken. The pre-stressing force is not included over here. See here, what I will be showing is the envelope diagram. So dead and live. So you will be having a M max, that is maximum bending moment, and M minimum. So we can't tell this as minimum. Sometimes in negative also we have so much of moment over there. So we can also get a minimum also in huge amount because it is negative. Okay. Then the moment from your envelope diagrams should be represented as M0 diagram, that is envelope diagram, and it does not depends on pre-stressing force. So when the pre-stressing force plays into the picture is when you have a beam, if you have a tendon profile like this, E is your eccentricity. So this much eccentricity we have been placing the tendon. So the first diagram is when I stretch the cable, you will be getting a bending moment, that is P into E force into the distance. So this is your first M1 diagram. This is your primary moment. Whatever the force you have given, what is your distance traveled? So this is nothing but initial moment P into E. That is, we can call that as M1 diagram. Then after the load is been acting, you will be having a tendon will be getting its all your dead and live load, right? So see here, this is your 2-span continuous prestressed beam. So if you don't have any interior supports over here, when I stretch the tendon, your beam will go like this. Okay, it will be subjected to upward deflection. So when you have a support here, okay, when you have a support here, obviously it will comes down. So this is nothing but secondary moment. So when you induce it here, it will be secondary moment. When it is not there, the pure moment is PE into E. This is your primary moment. Initially, what you are getting only due to the force and eccentricity is primary. And after taking care of all your reactions is your secondary moment. Then this is the diagram showing the 2-span continuous beam. So the free body diagram, I'll be showing it here. So first one, WL squared by 12, you will be getting, that is 4 times P into E. Then the secondary bending moment, 5WL squared by 8, that is 5 PE. Then combining all together, you will be having a positive over here and negative over here. So this will be given it in the M2 diagram. Okay. So the resultant moment should be calculated in this fashion. M1 due to eccentricity and the pre-stressing force, and M1 dash is nothing but due to reactions at your intermediate support. When you place the reaction, you will be getting an additional moment, right? So that additional moment you add பண்ணிட்டு தான் you should take your final resultant moment. So that additional moment we can call that as secondary moment. So this is the main important terminology in continuous beam: primary moment and secondary moment. When the secondary moment comes அப்படின்னு கேட்டாங்கன்னா என்ன எழுதுவீங்க? When the intermediate support is placed and the reactions is being held over there, you will get the moment there. That moment is nothing but your secondary moment. Okay. So these are the basic definitions that has been given there in your book. So pre-stressing force is been acting at an eccentricity E, so that the hogging moment will be developed P into E, that is called used due to the resultant reactions provided in between. Okay. Then finally combining those two, you will be getting a resultant moment in this fashion, right? Then so finally you will be getting a bending moment diagram in this fashion. So this is nothing but linear elastic redistribution of your moments. First it will happen like this, then it will move on. So if one needs, one will be taken care. So that this is the beauty of structural integrity over there. Okay. Then how to make use of this continuity, how to achieve this continuity in terms of pre-stressing. We can provide different types of cables. One is being in the form of sine curve continuous cable, and if you have a haunched bridges, you can provide straight cable. Then you can provide cap cable. Then you can provide intermediate straight tendons also. Okay. So see here, this is the curved cable. இப்படியும் place பண்ணலாம். So the higher resistance to your stress level, it can go for longer span. One disadvantage is friction. Okay, that friction can be avoided by placing straight cable. Here the hinged portions will be there in your structure itself. You can reduce your concrete over there. So the curved tendon can be replaced by straight, but the behavior is same. Okay, the wide web is necessary over here, and the large anchorage blocks is also needed, and skilled workman is also needed because you want to provide a hinged over here. Okay. Then you can go with overlapping tendons also. This is also nowadays they are doing it inside. Okay. So this is what we have seen in pressure line or thrust line. We can call that as pressure line or thrust line. So stretch பண்ணும்போது எந்த pointsல move ஆகுதோ, that is called as pressure line. That is what it has been incorporated. Before entering into the picture, I have told you about this pressure line, right? Then After doing everything, this profile will transform to something. That something is nothing but the transformation profile. Okay. So how it is being transformed? It is being transformed. Eppadi maarichu primary lende secondary lende resultant eppadi maarichu. That transformation can be done only through the pressure line. So that pressure line we can call that as transformation profile. So it may tendon profile consisting of straight lines between your supports and having zero eccentricity at your all your supports. So when the tendon follows such profile, it will produce your support reaction and your uniformly longitudinal compression, but no bending moments over there. Only the pressure is being building up over there. It will be transforming from one form to another. That time you won't get any bending moment. So that area is nothing but transformation profile. So we have several methods to analyze your secondary moments. As I said, 3 moment, consistent deformation, tendon reaction. So many methods are available. Then mostly adopted method is Clapeyron theorem. That is, it is a 3 moment theorem. It is giving the relationship between your bending moment at 3 consecutive supports. 3 consecutive supports, we can take all your moments, and you can also calculate extra moments what is being generated during the settlement also. So this theorem we can go with that. Okay. So from that you can take your resultant moment with the combination of MP and MS. So from that, where the pressure line has been building, also we can calculate. EP is nothing but where the pressure line has been there. So the resultant moment divided by your pressure with your eccentricity, you will be getting the EP value, the line of your pressure line. Okay. So this is what I would like to convey today. I think it will be very useful. So when we go for a huge structures, the analysis part is very tedious when compared to the design part. So while going for pre-stressing also, it will be very tedious only. So looking above your structure is very beautiful and very elegant, but at the outset, the back work is very critical. I think so. Okay, any queries? Any queries from the participants? So everyone is muted, right?
Thank you so much for your awesome session, ma'am. It's time for query session. Do participants have any queries? The resource person is now available to answer your queries. I repeat, does participant have any queries? The resource person is now available to answer our queries.
Yes, Amal Krishna. Yes, come on.
A kind information. Now every participant can also access mic and video. Do you have any queries? You can ask.
Nobody is having any queries? Everyone slept or you all understood? Okay, I think no queries. Shall we conclude, ma'am?
Yes, ma'am. Yes, ma'am. We hope that our audience has a clear vision and understanding of today's session. Thank you so much, ma'am, for this session. Let's wind up this evening with a warm note of appreciation. It's time to propose vote of thanks. I would like to call upon Mr. Veera Raghavan from the Department of Textile Technology to propose the vote of thanks.
Gratitude is a quality similar to electricity. It must be produced and discharged and used up in order to exist at all. Today, I take the opportunity to put all my gratitude into words. I consider it a great privilege to propose a vote of thanks to all the dignitaries who have witnessed it as a memorable and successful. On the behalf of KS Rangasamy College of Technology Institutions Innovation Council, I would like to express my gratitude to our Honorable Chief Guest, Mrs. B. Preetha, for taking her precious time out and delivering a speech on the topic. Innovation techniques in prestressed and concrete construction. Ma'am, indeed, your words have inspired us. Today's webinar was full of knowledge and interesting, gave us deep insights into the topic and also revealed some interesting facts. Thank you, ma'am, for sharing with us your words of wisdom. You took this event to a greater level. We will looking forward to have a more of our present future. We thank you for it as made a proud. I accept the of Vice Srinivasan and of KSRCT, special mention of respected our global president of our country. With a deep sense of appreciation, we thank our loving teachers for their untiring efforts. I would also like to thank the people who worked behind the scenes to make this event, President, Vice President, and the convener of this IAC, faculty coordinators and the student coordinators. Also, thank you to all the students present here for paying your attention and learning. Thank you all.
Thank you. Thank you all for your valuable time with us. Hope this session would have rewarded you with the valuable take-home benefits. Instruction: we kindly request all the dignitaries to turn on their videos to capture the moment. I repeat, we kindly request all the dignitaries to turn on their videos to capture the moment. Thank you, dignitaries. The feedback link will be shared in the chat box. We request all the students to fill out the feedback form. Thank you all for your valuable time with us. Now, the meeting has ended officially. Thank you all. This is Niveta signing off from MC Desk.